Hey there everybody, today we'll be doing Iterative, Tower of Hanoi. So in this problem, I have referenced the codingninjas.com and looked at their particular solution of iterating through the Tower of Hanoi. I found that their problem and their solution was one of the better solutions. And so let's go over it. If you haven't gone over the recursive solution, please go over that because everything we'll be doing is based on what we learned from the previous problem. And so how are we going to solve this iterative Tower of Hanoi? Again, we are moving items from between three poles, one called the auxiliary, one called the source, and one called the destination. And we're trying to get all three items onto the destination properly. So how do we do it? Well, what we can do is figure out the steps one at a time. So there are only 3 total steps that we can take. That there's a pattern to it, and we can get this pattern by looking at the example, doing one example, and for each example we get to learn something. So let's start with the first example. The first example is going to be the one to the destination. So if we take n mod 3, and that's going to be equal to 1, then we're going to move from source to destination, or vice versa. That means when it, depending on which one's empty, or depending on emptiness, and larger or smaller. So the reason why we're skipping the understanding and the matching part is because we have done that. The understanding is we do it iteratively. Period. That's it. That's all. We don't have to like do anything else. We're not gonna test anything like. We're not going to test anything like a 0 or a -1. We're just going to straight up follow from the recursive solution, right? So our match is that we're going to do iterative. There's no choice. We have been given this particular problem. We're doing a plan now. So that's number 1. Let's try 2 items, right? So with 2 items, let's say we have done the first move, right? And now we have the second move. So what is the second move? The second move is to move from the source to the auxiliary. And so that is the second move. There we go. What is the third move? The third move? Well, the third move is to move from the I guess the destination to the auxiliary, or vice versa, depending on emptiness, or larger or smaller. So because this is smaller, we're going to move this to our auxiliary, and we are done. So for evens, it looks like our auxiliary is going to be, we have to swap. So for even nums, we swap the auxiliary for destination. And now for the third item. So suppose we have 3 items, right? Now we have done a lot of this work already. And following our rule, we are near the end of all our room. So accordingly to our third solution, we're going to have to move these items. So we have a 2 here, and we have a 3 here. So accordingly, we have just completed this third move. So now we're trying the first move again. So we move from source to destination. Now this is at the destination, right? Then we move from source to auxiliary. So between the two, which one's empty? This one's empty, so we move the 1 into the source, and now we move from destination to auxiliary. So the 2 goes over to the 3. And lastly, we're going to move from the source to the destination, which moves the 1 into the last place here. And we have solved the Tower of Hanoi in 7 steps. So these are the steps that we need to take. And so this is the plan. We have several things we need to do. We have these 3 steps. We have make sure it's even. And the last step is the total number of moves is 2n, n being the number of disk, minus 1. We learned this from the previous video in the recursive case, where we found out that we looked at the solutions and we found the pattern where suppose we have 1 disk and that's 1, and then we had 2 disk and we had 3 moves, and then we had 3 disk and we had 7 moves, and so on and so forth. We have 4 disk and we had 15 moves, and we have 5 disk and we had 31 moves. So we found that pattern, and that's the number of moves that we need to make based on the 3 possible moves that we can take. And given all of these items here, we can plan out our solution. So let's start out by creating our stack. We're going to do this all in the stack because I found that this is the most, I guess, best way to do this, because it makes everything very clear to the coder and the people who are reading the code as to what is going on from the source to the destination to the auxiliary. And it just makes everything very easy to read and code out. So that's what I'm choosing to do. I'm going to make a class called stack, and everything's going to happen within this stack class. So first of all, let's define the init function and what we want in this particular function. We want to be able to show move. So that's one thing we need to do. So let's just set our stack to begin with. That's our stack, and let's set our capacity, because we need the capacity to know when we should stop moving items, popping items, and we need to know when we have hit the top or not. Okay, so let's define some things that we need to do. So we want to show moves. So to do that, we need a from peg to a to peg and the disk that we're showing. And so let's print moving disk from peg to peg, moving disk. Okay, with that, we're done with show move, and we also have to be able to move the disk, right? And we're going to follow this particular format and move disk. So we have to have a source, a destination, and we'll have the names for the source and destination that we're taking. So with these 2 functions, we'll plan out what we need in our stack to make sure that this works. I'm pretty sure that we'll be needing a push and a pop to fulfill our needs. So let's figure out what we need. So let's start with move disk. So we're going to get the poll 1 equals to self.pop, the source, and poll 2 to be equal to self.pop, the destination. Okay, and if the poll 1 is equal to, let's say we didn't see anything in there, let's return -1 there. Okay, so So we do need a pop function immediately. So definition, pop, self, and that's it. So what are we popping? Oh, we're popping a stack. Excuse me. And so if the stack is empty, stack equals length stack equals 0, then we're gonna return -1. So that's one way to get the empty. Is that good enough for us? I think that's good enough. Otherwise, we can create is empty function, or top is equal to -1. But meh. Or we can create a function called is empty, which is more like standard, I think. So let's just do it that way because, well, I think that's maybe better. We can change it if it doesn't work out. Top equals -1. So I don't know if this is the best way to do it, but anyways, otherwise, let's just pop the item. Give me a moment. All right, let's return the stack, this popped item from this particular stack. Okay. So what we're dealing with right here by having this top item is that we make sure that everything is arranged to the top and that we need to update this top item. However, we do have the length option to set the length of the item to see that that's 0. I don't think the top is necessary. However, I do think that maybe getting the length of our stack.stack is a little finicky, but we also have to get the stack.top. So I think it's fine the way it is. Let's just keep going. So now that we have done the pop, we can, if pole 1, that means pole 1 is empty. That means that the source is empty. That means we'll be moving the disk from the destination to the source. So that means, so destination dot push pole 2, right? And so self dot push to the destination of pole 2. And sorry, it was we're pushing to the source from the destination because the source is empty. Pole 1 is empty. So we're pushing to the source, and so self.show moves, we're gonna set that to be from peg. We're gonna set it from the destination to the source, and we're going to move the disk called pole 2. So we do need a push function. We're gonna push a particular stack, and if self is full, the stack is full, then we're going to just return. We're not going to push anything on top. So stack is gonna top is gonna plus equals 1, and what we're gonna do here is the stack dot append. We're gonna append, of course, this item. And so now we have appended the item into our stack. Okay, so we have everything done. Let's check out if poll 2. So let's make a couple comments. So if poll 1 is empty and poll 2 is empty, right? That means we're gonna push to the destination this time because the destination is empty. Okay, now we are left with which one's larger or smaller. So if poll 1 is smaller than poll 2, that means that we need to move the item from poll 2 to poll 1, and then we'll just stack everything on top of that. So we're gonna self dot source dot not self, sorry, self dot push. We're gonna push the item from the destination to the source. What we're gonna push is poll 2, and we're going to self dot push put the poll 1 on top of give me a moment. Sorry, poll 2 is larger. That means we're going to a destination. I knew something was fishy, so I didn't want to stop for a moment to think about it. And so we are moving to the destination. So we're going to go to the destination from the source, and we're moving poll 1 to the destination. Lastly, if this means that poll 1 is bigger than poll 2, so we're going to move poll 2 onto poll 1. Poll 1 is bigger than poll 2, so move poll 2 on top of poll 1. So that means we're moving items to source. So self.push source poll 1 and self.push source poll 2 and self.show moves from the source to wait. Give me a moment. So yeah, this is actually we're going from the source to the destination, and this is from the destination to the source, which is poll 1. So we're moving poll 2 onto the source, which is poll 1. Okay, with that, we have done the move. We've done everything that we need for stack, and we're ready to show how to do the solve of Hanoi. Let's move these 3 plans. I'm not even like showing properly what code. Actually, this is not good. So hopefully I'm showing. I'll just move everything to the top of the page so that you can see what we're doing. Otherwise, you can. So solve Hanoi. So this is another self, and we're going to be taking in a source, a auxiliary, a destination, and that's how we're going to solve it. All right, so we have a naming scheme. So that is S, D, and A, which is going to be S, the destination, and auxiliary. And those are going to be for our print statements. So this is the from peg and to peg. We'll be using this, as you can see, when we do the move disk. So let's do this. So first things first, like, how do we know how many moves we need to take? So let's set the total number of moves equals to 2 times n, 2 to the n. So basically, this is going to be a power function of 2 to the number of disk. Do we have number of disk in our function right now? And the answer is no, we don't have that number. So let's grab it. So 2 to that number minus 1. And we need to make sure that this is an int. So, okay, we got total moves. To n minus 1. We also need to make sure that even swap auxiliary and destination. So well, let's do that. If num mod 2 is equal to 0, then we're going to swap the A and D. Let's do that. So even, if even num, swap those, and total move is equal to that, to n minus 1 moves needed to complete problem. Now, time for meat of the problem is that we need to fill up our Tower of Hanoi, the source. So I is going to set to be the number, so that we can get the total number of plates. And we're going to say while I is greater than 1, then we're going to fill, well, then we're going to greater than or equal to 1, then we're going to fill this up. So source dot append I, and once the function ends, then we will have, sorry, I was thinking a little bit funny there. So we do need a self.push function that we have that, and we're going to be pushing to the source at I, and I minus equals 1. So we're going to reset I to 1, and while I is less than the num, we're going to keep moving in that direction, less than or equal to num. Sorry about that again. It is the total number of moves. So make total num moves. So we're going to go to total number of moves. We're going to start at 1, and we're going to make total num moves. And we're going to fill up the tower. Okay, so we filled the tower with plates in ascending order, and now we're making total number of moves. And we're gonna do exactly if I is mod 3 is equal to 1, yeah, then move disk so we're gonna do self dot move this from, so it looks like everything has to be top of page. So move disk is source destination. So we're gonna move from, I'm hoping that you can see this. So from source to destination, SD, and we're gonna do a, I think that shows the move as well. So that's all we have to do for that part. So if I mod 3 is equal to 2, we're going to move disk from the source to the aux, and we're going to have A as our aux instead. So, and lastly, we're going to, well, elif I mod 3 is equal to 0, self.move disk from the destination to the auxiliary. So des to aux D and A. With that, we have made the total number of moves, and we do need to make it I plus equals 1 after that. And with that, we have solved the Hanoi problem. So let's check it out. So let's say source, let's say num is equal to, let's say 3. That's very reasonable. And let's say source is equal to stack of 3. Well, aux is stack of 3. And the destination is equal to stack of 3. So let's make a solution equals stack of 0 and solution. We're going to run solve Hanoi, and we're going to take the num, the source, the aux, and the destination, and we're going to solve this problem. Let's run it. Hopefully we don't run into any problems. Looks like we have a problem already, and we have stock is full. We don't have that, so return stack.top is equal to stack.capacity minus 1. Run. Okay, so the from peg and to peg is not, it's D and S. My bad. S and D, S and D, D and S. So those are names and of what we're actually doing. Let's run again. And we have the moves. We have a total of 7 moves. Perfect. And with that, we have solved this problem. Oh my gosh. We have done it. Solved it iteratively. And this has really given me a strong workout on how to create stacks and use stacks to do this particular problem. I highly recommend that you give this a shot and see how it's done and why exactly we want to write out the code in this manner. I mean, technically speaking, we should be able to just do this instead. I don't exactly know why we chose to do this way. I don't really understand it myself. I think if we are able to do this, we should be able to do it like that. We should just return that. That's what I think. Okay. Let's run it. Whoops. We popped from empty list. Okay, never mind. It doesn't work that way. So we do need a top function so that to make sure that we don't actually pop anything. Yeah. Okay. So I learned something today, and I hope you did too. From this, let's learn some more and do more problems and understand how to use different data structures and get more practice with them. So this is great practice, and I definitely learned a lot here, and definitely will use this as a template for future stack type problems to dealing with stacks. And I will see you in the next one. Thank you. Bye.